So, hi everyone, welcome back to Concept Craft. This is me Pratyush Kumarkar, and in today's lecture we will be studying about today's session we are going to study about class 10th science, and that too the physics, which everybody feels that it is a bit difficult. That we will be studying about light in the first lesson, light, reflection and refraction. We will be going to studying about light, what is reflection, what is refraction, but in today's session our focus will be totally on reflection. Today is part 1, and in this part 1 session we will be studying about reflection. The part 2 we will be studying about refraction. So let's get started with high energy. So basically in this there are various numericals. I will make you to revise all that numericals in that next video. Means after refraction one more video will be uploaded on this channel itself, which will be only on numericals. So you must watch that for your betterment in numericals. So let's get started today's session, that is light reflection. So basically before starting a reflection we will be known what is light. Light Light is a form of energy which enables us to see things around us. Sun is the major natural source of light. So basically, the first point says that light is a form of energy. It is a means like a form of energy, like solar energy, wind energy, water energy. Even light is also a form of energy. What does it enables? It enables us to see things around us, and in that sun is a major natural source of light. Coming upon the second point, light is a form of electromagnetic wave which does not require any medium like solid, liquid or air to propagate. So what does this point says? That is, light is a form of electromagnetic wave. There are various waves. In that, one wave is electromagnetic wave. So in that we will be studying about electromagnetic wave in your higher classes when you come to 11th and 12th. So basically remember, it is a type of wave, like ultraviolet wave, infrared wave, visible color wave. Similarly, it is a type of electromagnetic wave. It does not require any medium like solid, liquid or air. Means it can means like it can move from one place to other without any medium. Like in vacuum also it can move. Next point comes is velocity of light is 3 lakh kilometer per second in air or vacuum. So speed, velocity means speed. You would be studied in your ninth class that what is velocity, what is speed in the lessons force and motion. So in that the velocity of light is 3 lakh kilometer per second or 3 into 10 to the power of 8 meter per second. Some of them are right here. So this was light. We said what is light, not light, what is light. Introduction. Now, some one term comes here, rectilinear propagation of light. In your, I guess, 8th standard, you would have studied about it. What is rectilinear propagation of light? Let us read the definition. Light always travels in a straight line. This property of light is known as rectilinear propagation of light. What does it basically says is, so light always travels in a straight line. It is not like our Indian roads, which sometimes goes to some gullies and then get turned over, crisscross, zigzag, everything. No, light is always straight, like who can we take example? Straight like rod. It is every time straight and it moves to straight line. So there is an experiment which is there given in a picture, that a boy has taken three cardboards and he has made a hole on the same alignment, and he saw a candle flame from that holes. He saw that the light came in straight. But if he was moving one of the cardboard, then he could not see because light's path is blocked, as light always travels in a straight line. So this was rectilinear propagation of light. Clear, sorted. Let us move to next topic. Next is reflection of light. The lesson's name, that is light, reflection and refraction. In that the first topic, reflection, we are going to start today. So with high excitement, let us start this topic. What is reflection of light? Let us read the definition. When a ray of light falls on an opaque object, it bounces back. This phenomena of bouncing back of light from an opaque object or surface is called reflection of light. So basically what this all big English sentence means is, a light comes, it falls on an opaque object, more specifically smooth polished opaque object. When it falls, it gets reflected, means the light path is diverted or gets reflected. This is called reflection of light. Simple. In this below picture, you can see that a ray of light, that is in, I will say you what is that incident ray, reflected ray. So a ray of light comes, it falls on a mirror. When it falls on a mirror, it gets reflected and moves in different direction. That is this is called reflection. That's it. What is reflection? The bouncing back of light from an opaque object is called reflection of light. Simple. Sorted. If we move to the most important topic of reflection lesson, that is laws of reflection. What is laws of reflection? So our scientists, what no, after discovering that light is reflected from one medium to another medium, they did not sit quiet. They thought that no, we have to do some golmaal with this. So what did they do is they discovered laws. You have studied laws of motion, laws of this Newton laws of motion, everything. Now of light also they have discovered some laws. So in reflection also there are two laws, and in reflection also there are two laws. So if we see reflection two laws, first law is incident ray, reflected ray, and the normal at the point of incidence all lie on the same plane. Now what is incident ray, what is reflected ray, what is normal? So the light which comes from a source means, listen carefully. The light which comes from the source and falls on a mirror or any of the plane surface is called incident ray. On the picture you can see a line which is coming and hitting the mirror. Which is hitting the mirror is called incident ray. It means the light which comes from a source and hits the mirror is called incident ray. Reflected ray is the ray after, means after hitting the mirror it gets bounces back, and that bounced ray is called as reflected ray. Now, what is normal? Normal is an imaginary line which is drawn perpendicular to the surface. Let it be mirror or object or anything. It is an imaginary line. You can see here a dotted line of normal. It is drawn, and it is imaginary. It is perpendicular to the, means like mirror here. We can take any other thing also. So it is perpendicular. That's it. So this is like incident ray, reflected ray, normal. What is point of incidence? Point of incidence is the point where the incident ray, reflected ray, and the normal meet. Means you can see in the image that in a mirror there is a point where incident ray is hitting, that is a point. Reflected ray is getting bounced back, and normal is drawn here. So the point where that all three lines meet is called as point of incidence. The first law says that incident ray, reflected ray, and the normal at the point of incidence all lie on the same plane. What does this basically mean? That all these points, that incident, reflected, normal, point of incidence, all lie in the same plane. Yes, it is true. Mirror is a plane. We can say mirror is a plane, is a plane surface. So on that, incident ray is also there, reflected ray is also there, normal is also there, and point of incidence is also there. The first law says that simple sorting thing: incident ray, reflected ray, and the normal at the point of incidence all lie on the same plane. That's it. Next law says that angle of incidence is always equal to the angle of reflection. Now, what is angle of incidence and angle of reflection? So now you see the incident ray is hitting the mirror and a normal is drawn. So the angle between the incident ray and the normal, carefully listen it. What is angle of incidence? The angle between incident ray and the normal. Between normal and incident ray is called angle of incidence. Will be represented with I, means small I. Angle of incidence is angle between incident ray and the normal. Angle of reflection, angle between reflected ray and the normal. So they have given here angle of incidence is always equal to the angle of reflection. Whenever you go to your lab, you can just try it out with your paper. I guess so. It is there in the NCERT activity. You can just try out that activity by using a piece of paper. So these two laws you must remember. Questions can be asked. I will bring you a question video also. Incident ray, reflected ray, and the normal at the point of incidence all lie on the same plane. Angle of incidence is always equal to the angle of reflection. These are the laws of reflection. Moving on to the types of reflection. What is types of reflection? There are two types of reflection. One is regular reflection, one more is irregular or diffuse reflection. So what is regular reflection? Regular reflection means whenever a parallel beam of light rays falls on a smooth and polished surface, then after reflection, the reflected rays are also parallel to each other. What does this mean? This means that, I say you one thing, light beams, like light rays, are always parallel to each other. You have read about parallel lines in your maths. So they are parallel to each other. These rays are parallel to each other. So what happens is when this parallel beam of light falls on a smooth and polished surface, like it falls on a mirror or any like very shining surfaces, when it falls, it is smooth and polished. So when it falls after reflection, the reflected rays are also parallel. So when initially the parallel beam light comes and falls on a smooth and polished surface, then after reflection the reflected rays are also parallel to each other, and they get reflected back, means they are also parallel to each other. What does this reflection cause? This is called as regular reflection. So regular reflection is A beam of light is parallel, comes, gets reflected, and again goes back parallelly. So the work total is parallel. The irregular is totally opposite. Irregular is also called as diffuse. Now don't get confused in exam if they ask regular and diffuse, then don't get confused. Diffuse and irregular both are same. The question is not question, means like the definition says that whenever a parallel beam of light rays falls on a rough and unpolished surface, then after reflection the reflected rays moves in a different direction. Did not understand? I know that. I will explain you. Simple. The parallel beam of light rays comes, it falls on this time a rough and unpolished surface like table, desk, or chair or anything. Like it is a, like a rough, right, and unpolished. It is not like polished and made it so plain. Rough and unpolished. So when the parallel beam of light rays hits, so due to some like excess like what we say, the irregularities on the surface, because of that the light rays does not get reflected in one angle itself, it gets reflected in different directions. So it is called irregular or diffuse reflection. I guess this is sorted out. If I take the example, see, means like not example, a diagram. If you see regular reflection, you see that an incident ray which is gray in color, it is coming, hitting here and getting, and red color lines are reflected rays which are going, and you can see that the rays are parallel to each other. But here you can see that the irregular reflection, there is like hindrances or irregularities on the surface. Because of this irregularities, what happens is a parallel beam of light rays comes, hits, but it gets reflected in different directions. See here, one line is going this way, one line is going parallel to that line, third line is going somewhere, and fourth line, fifth line and fourth line are meeting each other, fifth line is going totally different. This is because the irregularities are causing directions to be changed. This is regular and diffused reflection, or means types of reflection ends here. Now comes the most important topic, reflection by plane mirror. What is a plane mirror? First, let us study about what is plane mirror. A plane mirror is made by a glass which is coated with silver, as silver is the best reflector of light. Now, actually, plane mirror is nothing but a piece of glass. Okay, the glass, what they do is they take a piece of glass, they just coat the back of the glass with silver. Why they do so? Because silver is the best reflector of light and it reflects the light very easily. And so, due to which a plane mirror is formed. Simple. Plane mirror is just a piece of glass in which silver is coated, as silver is the best reflector of light. That's it, is plane mirror. So how image is formed by plane mirror? You can see here the angle of incidence must be equal to angle of reflection. The plane mirror, the middle brown color piece is plane of mirror. When an object is kept in front of the plane mirror, then the image is also formed behind the plane mirror, which is virtual and erect. You will be studying what is virtual, what is erect, but I'm just giving a brief summary that how the image is formed. You can see that image here, image of the image formed by the plane mirror. Okay, let us move to the next topic. Next is most important, like it is like a GK question. What is lateral inversion? So lateral inversion is when an object is placed in front of a plane mirror, the right side of the object appears left and the left side of the object appears as right. This change of sides of an object and its mirror image is called lateral inversion. This is due to the reflection of light. What and all these English words and lines mean? This thing means that, simple. Whenever you stand in front of a plane mirror, you means you can try this experiment at your home itself. You go in front of a mirror, like plane mirror, and just stand in front of the plane mirror. You will see that you when stand after standing, you just lift your right hand. Whenever you lift your right hand, you feel that in your image the left hand is getting lifted, and whenever you lift your left hand, the right hand will be lifted up. So this change in the side, like left, if it like lift your right side, left side will appear. If you like lift your left side, right side will appear. This change in the side of the object and the mirror image is called lateral inversion. Simple. Just the scientists and who have like physicists and all who have given this name, they just want to confuse you. They could have given the simple easy terms, but just they want to trap you in their words, so only they have given these many terms. Right side becomes left, left will become right in the mirror. This is called lateral inversion. Simple. Let us move to next. Means like this is the image. If you see lateral inversion, you are means like a person is lifting his right hand in front of the mirror, but here in image the left hand is being appeared. So this is due to lateral inversion. Now next is characteristics of image formed by a plane mirror. What are the characteristics of image formed by a plane mirror? Image formed by a plane mirror is virtual and erect, cannot be obtained on the screen, same size, same distance behind the mirror, lateral inverted. First point is right, virtual and erect. That I will explain you in the next slide. First, let us read this thing. Cannot be obtained on the screen. Now, a screen is a thing in which we can see the object. Now, if you see mirror, mirror doesn't require any screen because we are directly seeing the object. Means like image we are seeing directly in the mirror. If we cannot see, then we need a like screen to see that where is the object or the image. So it cannot be obtained on the screen. If we keep a screen like surface, then also we don't means like we cannot be that object or the image cannot be seen. And same size. This is obvious thing that plane mirror obviously forms the same size. If it forms different size, then your mirror is I guess so haunted. But it is the same size. Next is same distance behind the mirror. That is how much distance you stand behind the mirror. That much distance it stands in means like if you stand how much distance you stand in front of the mirror. That much distance behind your image stands in the mirror. That's it. Laterally inverted. That you have understood that what is that lateral inversion. Next, types of image form. One is real image, one is virtual image. Real image, as the image suggests, real image is real, means that can be caught on the screen. Real image is the image that cannot be caught on the screen. And real image is always inverted. Inverted means upside down. If you like how to explain real image, imagine you are seeing your real image on the screen. That in how the real image will be like, your leg will be up and your head will be down. This is like little weird, but this is a real image that it will be inverted, upside down, and it is formed by the actual intersection of light rays after reflection or refraction. Means it is formed by the actual intersection, not by virtual intersection. The real image it can be caught on the screen because it is real, so only it can be caught on the screen. Real image is always inverted, it is always upside down, and it is formed by actual intersection. Coming up on the next thing, that is virtual image. What is virtual image? Virtual image cannot be caught on the screen. Why? Because it is virtual. It does not exist itself. It is just formed virtually. It doesn't exist only. Then how can it be caught on the screen? So virtual image cannot be caught on the screen. Next is virtual image is always erect. Means it is always up and straight, not like that upside inverted in the real image, and formed by the virtual intersection. Simple. Real image is real, virtual image is virtual. Don't write that definition in exam. Real images cannot be can be caught on the screen. Virtual cannot be. Real image is inverted. Virtual image is always erect. That's it. Remember? Sorted. Let us move to the yeah, you wanted to see the image. The real image will be always upside down like this, and virtual image it will be means like light will be reflected. But what we means we means like when we stand in front of the mirror, the light rays after getting reflected they move in different direction. But what happens is the rays are pulled backside and a virtual image is created at the back of the mirror. That is a virtual image. You will study more if you take physics in your 11th and 12th. Moving upon the most important topic, that is spherical mirrors. What is spherical mirrors? Simple as the name itself suggests, a spherical mirror is that mirror whose reflecting surface is part of a hollow sphere of glass. Simple. What happens is we take a hollow sphere of glass. What do is we cut according to the shape, means like two types of in that shape we cut it. One side we coat it with silver and the other side we leave it, and that acts as a reflecting surface. Simple. A spherical mirror is that in which the reflecting surface is part of a hollow sphere of glass. There are two main types: concave mirror, convex mirror. Means like keep an eye on the spelling and the words. Concave mirror, convex mirror. So what does a concave and convex means? Like we have the types right in the difference between I have made and I have brought it. So what is concave mirror? It is a spherical mirror in which the reflection of light takes place at concave, curved inwards. Concave means curved inwards. Cave, you know, no, cave means like you have seen that Ellora caves and all like lions cave. So cave means what? It is inside, like the place is inside. So like that you can remember concave means it is curved inwards. Inside it is curved. And convex means it is curved outside. Outside it is curved outside. The concave opposite is convex. That's it. So concave is it is a spherical mirror in which the reflection of light takes place at the concave surface, also known as converging mirror. So concave mirror is like it is curved inwards. It is known as converging mirror. What is converging? Converging means a beam of light is coming. It whenever it means a converging mirror are those mirror, it makes the light to meet at one point. So when the light gets reflected, it makes them to meet at one point. So it is called converging mirror. Diverging mirror is it's like say opposite. When the beam of light comes, it makes them to diverge. It splits. It splits them into means like more angle. It splits. It is converging. It is diverging. Concave is curved inwards. Convex is curved outwards. Simple. Sorted. Let us move. Now you can see the image types of spherical mirror form. This is concave mirror. This is convex mirror. So concave mirror, you can see it is curved inwards, and the object is getting reflected. In convex, it is getting it is curved outwards. And one more thing I say you, most importantly, concave mirror always forms a real and inverted image, whereas convex mirror always forms virtual and erect image. Remember, virtual always with virtual erect will be there, and always the real inverted will be there. And concave always real and inverted, and convex always virtual and erect. Remember this, okay? Now let us move to term related to some spherical mirrors. Now we are going to study some terms which the scientists have given just to eat our head, not more. Just simply like they don't want to sit quiet, they have to do something or something to just eat our head. So we have some terms related to spherical mirror. First is pole. Pole means no, don't think the pole which you climb and go to somewhere. No, not that pole, or not the North Pole where you think that Santa Claus will be staying. Here the pole means, read the definition first. The center of the reflecting surface of a spherical mirror is a point called pole. The distances with respect to mirror are measured from pole. Simple. I will explain you with the image. So now forget convex. Now forget convex. Now see the concave. In the concave, you are seeing a point P. huh? So that point P, you can see that it is equidistant from the mirror's up part to the point P and down part from point P. So it is the center point. So in that mirror, the center point is called pole, and from pole only we measure all the distance, how much distance the mirror, like 20 meters, 40 meters, 60 meters, 80, 100, 200. That we measure it from pole. So pole is the center point. That's it. Remember. Next is center of curvature. What is center of curvature? Center of curvature of spherical mirror is center of the hollow sphere of glass of which the mirror is a part. Just a minute. Center of curvature means, now this is I said you it is a part of a spherical mirror, means like they cut the spherical mirror and they make it in this shape. Now if we totally like join this hole, means like if we like extend the curve towards and make it a circle, it will become a sphere, and in that sphere there is a like center point, right? Like not only in mirror piece, the pole is the center point of mirror, but if we take the hollow sphere of glass, like full sphere if you consider, then the center point will be the C. The C will be the center point if we extend that, and so that is called the center of curvature. That is the center of the hollow sphere of glass of which this mirror is a part. Simple, sorted. Pole is the center of the mirror. Center of curvature is the center of the sphere of glass. Simple. Let's move to the next is radius of curvature. The radius of curvature of a spherical mirror is the radius of the hollow sphere of glass of which the mirror is a part. Did not understand? Even I know that. So I'll explain you with this same thing. Radius of curvature means, don't read the definition. From point pole to it is a radius. If we see from C, from center of curvature, if we draw a line to any point, now if we take the radius of the circle, what we do? We take the point on the on the center point we take, and from center point we draw a line to the on the surface due to which we can measure the radius. Similarly, here also from center of curvature, we draw lines to different points to measure the radius of curvature. Simply, if you want to see, the radius of curvature is distance between a P and C. That is called radius of curvature. From pole to center of curvature, the distance is called radius of curvature. Moving on to next topic, that is aperture. Aperture, I know these words are a little new to you, but you must study this here. Aperture is the diameter of the reflecting surface of a spherical mirror is called aperture. Now students make what mistake here is, they say that curvature, if we extend curvature line towards this side, then it will be aperture. No. Now see the spherical reflecting surface of this mirror. On the reflecting surface, the down point to up point, that means the mirrors down point to up point, if we join that line, that line is called aperture. That is the diameter of the reflecting surface of a spherical mirror. So it is a reflecting surface, and in that reflecting surface, when we join that two lines, it becomes diameter, which is given the word aperture. Sorted. If we move to the next is principal axis. What is principal axis? The straight line passing through the center of curvature and pole of a spherical mirror is called principal axis. Basically, what does this principal axis means is it is a straight line. Let me explain. So, say principal axis is it is a straight line. So, what does the straight line? This is a straight line is only called principal axis. That definition that from which it passes curvature, focus, that thing don't need to eat your head. The straight line from P to drawn till infinity is called principal axis. Next stage is principal focus of concave mirror. Now, principal focus of concave mirror, convex mirror, these are different. So, let me explain you with the image. Now, if you just read the definition, I will like pin to you after the second part. I will pin that thing in description. You just see it. But for now, in image you see that what does it say? Focus means from P from pole to like just a minute. It is a point on its principal axis through which are parallel and close to the axis converge after reflection from the concave mirror. A concave mirror has a real focus and the focal length is always negative. Yep. So what does this mean is in the concave mirror, the rays are parallel to the mirror. When the rays after reflecting, they meet at a point. Means like parallel rays after reflecting, they get meet at a point. This point is called focus, and more especially principal focus of concave mirror. So this is a like point where the parallel rays meet after reflection in concave mirror, and in convex mirror it is behind the mirror as it forms a virtual image. Simple. Now this was for principal focus of concave and convex. You read the definition when I pin you the notes. Last thing is focal length. Focal length is the distance between its pole and focus. What does this mean? Pole and focus. That between distance is called focal length. Means the distance that means the distance between the pole and focus is called focal length. Simple definition I've written little easily. You can just identify and you can see, remember principal focus of like focal length, it is represented by small f. So it is like represented by small f because who will write focal length largely during solving the sums. It's only they use small f for that means like representation of focal length. Now coming upon relationship between the radius and radius of curvature and focal length. Don't think that relationship. We are talking about the relationship between radius of curvature and focal length. In simple language, I've written a radius of curvature is twice the focal length. Or in numbers, if you see, r means radius of curvature is represented by capital R. So r is equals to 2f. So means whenever they give a radius of curvature, understand that it is 2 times the focal length. And whenever they give focal length, and means whenever they give the focal length, understand that it is half of radius. Simple, sorted. Let us move to next topic. Next topic is most very to the power of infinity. Most very important. Remember, what is this? Is representation of images formed by the spherical mirror using ray diagrams. Now, what is ray diagrams? Ray diagrams are the diagrams which we draw using the ray. This was silly. Yeah, this definition is very much silly. The diagrams which you draw using a ray is called ray diagrams. And now we are going to study the ray diagrams of concave mirror. Means now we take an image and we, like object and we keep at different positions and we just see where means like where the image will be found in case of concave and even in the case of convex. So let's get started. First is concave mirror, that is object between pole and focus. So when the object is placed between pole and focus, I know you must be knowing the terms. If you don't know, just rewind the video again, study the terms. So the object when it is placed between pole and focus, the image is formed behind the mirror. So position of image is behind the mirror. Now you can see the nature. Nature means how it is, virtual or erect or real or inverted. So you can see that it is erect and it's virtual because it is formed behind the mirror. And size is magnified, it is bigger than the size of the object. Remember, in concave mirror only one case is there where it is formed virtual and erect, and rest all are formed real and inverted. Remember this. So if you see the nature, it is virtual and erect, size it is magnified, position it is behind the mirror. Now comes the next this is object at focus. What happens when the object is placed at focus? When the object is placed at the focus, the light gets reflected. You must practice these ray diagrams. I'll give you the notes. You just practice by draw. Once you see and draw, and without seeing you draw once, it will be best for you. So when the object is placed at the focus, then the image is real and inverted. Now you say there is no image form because the position is at infinity. It gets the rays are parallel, right? So it gets goes on parallel, so it goes till infinity. But in physics, what we do, we don't believe the term called the parallel rays do not meet. What do we do? It at infinity we make the parallels to meet each other, and a highly enlarged image will be formed. So that is called the like object and focus. What will be like this? I know you will be thinking that when the parallel rays will never meet, we have learned in maths, but in science the impossible things makes it possible. So what happens here is we make them to meet at infinity, and due to which a highly enlarged image will be formed, and nature is real and inverted. As you can see, it is real because it is not formed behind the mirror. Simple. Let us move to next topic. That is not next topic. Next, position. Object between C and F. C is center of curvature. F is focus. So when the object is placed between center of curvature and focus, it is formed beyond C. Like beyond center of curvature, it is formed, and the size is magnified. As you can see, the object size is small and the image size is very big. Remember, the red color represents the image, black color represents the object. So the image is formed behind the mirror, and it is magnified, and it is real and inverted. You can see real, it is inverted, and inverted means it is real. Now moving next position, object at center of curvature. This is a unique case. What happens here is the object, like when it is kept in center of curvature, it is found at center of curvature itself. So it is a unique case. I mean, the image after reflection of ray diagram, it is formed at center of curvature. The size is also same size, but in the nature is real and inverted. It is real and it is inverted. But this is a unique case, you must remember. Next is object between center of curvature and object beyond center of curvature. So when object is beyond center of curvature, then the position is between C and F. So between C and F it is formed. Nature is real and inverted. Size is diminished. So remember, this is beyond center of curvature. Lastly, the object when it is kept at infinity, like at very far distance, then the object will be formed at focus, and the nature will be real and inverted, and it will be highly diminished, point size image we say. So this is the concave mirror ray diagrams. I hope there will be no doubt. Again, you just revise once. Let us revise once. You must see the notes. What does it say? Object between pole and focus. Nature is virtual and erect. Size is magnified. Position is behind the mirror. So next is object at focus. It is real and inverted, highly enlarged at infinity. Object between C and F, real and inverted, magnified beyond C. Object at center of curvature, real and inverted, same size at C. Object beyond center of curvature, real and inverted, diminished between C. Object at infinity, real and inverted, highly diminished at F. So this was ray diagrams of concave mirror. Practice once, you will like have a habit of it. Moving on to next, that is representation of images formed by the spherical mirror using ray diagrams, and that is convex mirror. Convex mirror has two cases. Concave has six cases, but convex has two cases because scientists did not have that much brain to find still more cases. So convex mirror, there are two cases. First case is when the object is kept at infinity. When it is kept at infinity, then first thing is the nature is virtual and erect. I said you every time the convex mirror forms virtual image and erect image. So object is virtual and erect. Size is highly diminished. Point size we cannot see with our naked eyes. So size is highly diminished and position is at F. At focus it is formed. Next is when the object is between infinity and pole. So when it is for between infinity and pole, so what is formed? Image is virtual and erect. Size is diminished. It is very like small size, and position is between P and F. Between pole and focus, the image is formed. I hope the ray diagrams are clear. Moving on to the uses of concave mirror. Now, where this concave mirror means like scientists discovered it is a concave mirror, but where it is used? Scientists said, "Wait, I'm giving you the points. Don't worry." So he gave us the uses where the concave mirror can be used. First is torches, searchlights, and vehicle headlights to get powerful parallel beam of light. Means now I'm giving you at which places the object is kept so that we can get this image. So torches, searchlights, and headlights to get a powerful parallel beam of light. So with the light, the reflector in the torch, I don't know how many of them has dissected the torch, like they have like seen the inside parts of torch. Who have seen, they would have known that the reflector which is inside the torch, it is it is means like kept at the distance so that it can come near the focus, like not reflector. Reflector will be at place that like torch, like the light point or the source of light that will be kept at the focus of that reflector or the reflector, due to which when the torch is lit, the light gets reflected and goes till infinity. So the parallel beam of light is formed, and it goes. So at what point this we get at when the object is at f, that same case we get. So the scientists means like not scientists, the people have made the light to be kept in the f, due to which they can get a powerful parallel beam of light. Clear? If we go up on the second use, that is used as shaving mirror or makeup mirror. Like you would have seen that whenever your father would be like trimming or like they would have shaving the beard, or whenever if any of your mothers or anything would have been doing makeup in the mirror, you would have seen that the mirror makes little larger image. This is because the like mirror, when it is kept between like kept near the face, it forms a larger image, due to which they can easily like help them to cut the like shave the part. So what happens here is shave or do makeup. So here the case is object between P and F. If you remember, when the object is between P and F, the image formed is virtual, erect, and it is little magnified. I guess it is remembered. So this case is used in this uses. Next is used by dentist to see large image of teeth. Yeah, it is used by dentist. So the mirror which they use, same above case P and F. Last is used in solar furnace to produce heat. Solar furnace, it is a type of furnace which is used to heat and melt the like objects like at the aluminium steel factories and all. So they use solar furnace. Solar furnace, how they will like how it will help of the sun is at infinity. It makes the light to fall on the like the light falls on the reflector, and when the it is like a reflector itself, upon that a point will be there at the focus of the reflector, due to which when the light infinity light falls, it meets at the focus. When it meets, it produces heat at that point. At the point, I guess so. This have tried in convex lens also, that magnifying lens burning the paper. We'll study about refraction. In the refraction, we'll be studying about these things. Now, concave we have done. Now we will see the uses of convex mirror. It is used as simple. Now don't read this thing. I mean, it's like when I'll provide the notes that you read. It is used in vehicles that behind that will be there, right? The rear view mirror. In that the convex mirror is used because it provides a wider field view so that the driver can see easily, and uses parking mirrors. And sometimes at the malls and all, you would have seen that at a turning point where there is a like blind spot, there will be mirror kept so that the people can see that yeah, a vehicle is coming and they can easily drive it. Used as surveillance mirror. Now it is not used. Earlier, when there was no cameras, CCTV cameras in shops, they used to put this convex mirror so that they could see the total surveillance of the shop. So this is the uses of convex mirror. Moving on to sign convention for spherical mirror. Again, very to the power of infinity important topic. Very very important. Sign convention for spherical mirror. What is this? Children make mistake. Now for now, no, like I say in video, you don't read this. When you like, whenever I provide you note, you just read this thing. Now simply with the help of diagram, I will explain you. Now this is a mirror. Now the blue color thing is a mirror. Upon that, the principal axis of black color line is passed. Now what happens is, whenever the object is kept to the right of the mirror, the distances like distance, not the value will be in positive. I guess the first point. Now see, first thing remember, every time you remember, an object is always placed to the left of the mirror. This means that light from the object falls on the mirror from the left hand side. Remember, every time object is always kept on the LHS, left hand side. In maths, you have proved most of the time LHS is equals to RHS, that root 2 is irrational. You'll be proving that. So in that case, what will you means, every time the object must be on the left hand side, means not on the right, on the left only it must be there. Next is, all the distance measured parallel to principal axis are measured from the pole of the mirror. I said you right, from pole we measure the distance and all. Next is, all the distance measured to the right of the origin along the positive x-axis is taken as positive, while those to the left along the negative x-axis is taken as negative. What does this mean? Simple. What does is this? Now imagine this is a graph paper upon which the two lines are there. This mirror is a line and this line, like x-axis, y-axis, two lines are there. Now in if you have drawn that Cartesian plane, or I guess so in ninth you have studied about the coordinate geometry, where the left hand side the numbers will be negative, right will be positive, even up like line up the all the numbers will be positive, down will be negative. X-axis, x dash axis, y-axis, y dash axis. So basically what does it say here is all the distance measured to the right of the origin. So here the point P we will consider it as origin because two lines meet here. I guess you have remembered the Cartesian plane or the coordinate axis. So what happens is the pole we will consider as origin, and to the right of the origin the all distance towards the right will be positive. Similarly, all distance towards left will be negative. Similarly, all distance towards the up, perpendicular and above the principal axis will be positive, down to the principal axis will be negative. That is a sign convention. Simple. So, distance measured perpendicular to and above the principal axis along the positive y-axis is taken as positive. Distance measured perpendicular to and below principal axis along the negative y-axis is taken as negative. Simple. Understood. Sign convention. Again, if you did not understand, rewind the video and check why, because I don't want to pull the video that much long or else you will feel bored by listening. So this was the sign convention. Remember, if you did not understand, rewind the video and check this out. Moving on to the most important formula for the first part's numericals. We will study the numericals directly. The two parts numericals we will be studying directly in the third or fourth video, I guess. So mirror formula, what does it say? In a spherical mirror, the distance of the object from the pole is called object distance. Let me explain with this image. What does happen is the distance between pole and the object is called object distance. This like arrow which you are seeing above the principal axis is called object, and the distance between object and the pole is called object distance. Similarly, from this image to the pole, the distance will be image distance, and the distance from the pole to the focus will be like focal length. I guess you have understood this. And I say you, object distance we represent it with U. Remember? And image distance we represent it with V, small v. And focal length we represent it with F. There is a relationship between these three quantities which is given by mirror formula. Again, relationship we have to establish here. So what happens is the relationship says that 1 by V plus 1 by U is equals to 1 by F. So we take the reciprocals of the thing. So 1 by image distance plus 1 by object distance gives us 1 by focal length. Simple. But after solving, we have to just change the reciprocal. I will give you the sums how to solve that. I will myself, I'll by my handwritten notes, I will attach to this PPT and I'll show you how to solve that sums. Sorted. So mirror formula is object distance plus image distance gives the focal length. Simple. Now, coming up on the most important topic, magnification, or we say it as linear magnification. What is the magnification or linear magnification? The ratio of the height of the image to that of the height of the object that is represented by the letter small m. So, magnification means that it is a ratio of the height of the image to the height of the object. So, if you see in this image, you can see that there is a certain height of the object and certain height of the image. So what does the magnification says that the height of the image, remember, height of the image must be at top, height of the object must be at the bottom. So magnification simply says that it is a ratio of image height to the object height, and it is represented by small m. So you can see the small m can be, the height of image and object can be represented by many like things, hi by ho or h dash by h or h2 by h1. My suggestion is use hi by ho, it will be easy, I guess so. But if you wish, you can use these things. But my suggestion is that thing, magnification is the ratio of the height of the image to that of the height of the object. Next, one more definition. Magnification is also the ratio of the image distance to the object distance with negative signs. So, image distance is represented by V, object distance is represented by U. So, the ratio of these two things gives the magnification. Remember, there will be negative sign in the magnification. When it is written V by U, minus sign must be there. So this was magnification. The ratio of the image height to the object height, sometimes the image distance to the object distance with the negative sign. This was magnification or linear magnification. Things to remember, most important things to remember. Now magnification is given. Now if the magnification of the image has positive sign, then the image is virtual and erect. Okay. When the image is like has the magnification is positive, means like if the sign has positive sign, then it is virtual and erect. Negative means real and inverted. If the magnification is equal to 1, means like if m is equals to 1, then it is same size of the object. If the magnification is less than 1, m is less than 1, then the size is diminished, it is small size, and the magnification is more than 1, then the size of image is magnified. We are not talking about object, we are talking about the image. The image form is magnified. If less than 1, then the image is diminished, and it is equal to 1 is, then the image is same size. Now, a plane mirror always gives a magnification of plus 1. Now, plus virtual and erect, 1 same size, means that the image is virtual and erect, same size of the object. Again, let us repeat this things to remember. The magnification, if it has positive sign, it is virtual and erect. If it is negative sign, then it is real and inverted. If the magnification is equal to 1, then the image will be same size. If the magnification is less than 1, then the image size is diminished. If the magnification is more than 1, then the image is magnified. Plane mirror always gives plus 1. Means the magnification it gives plus 1, which means that the image is virtual and erect and same size of the object. Simple, sorted, clear. Now, this was whole the first part of our lesson, that is light reflection. We will be meeting in the part 2 with light refraction. We will be studying about what is refraction, what causes refraction, most important activity of NCERT, that is refraction through glass slab, and many more things. Stay tuned to get the notifications. If you like this video, if you means like if you're interested in these educational videos, please like this and subscribe to my channel so that you can get the real daily educational content of this NCRT and even the outside of NCRT. So till then, stay smiling, stay happy. Thank you and bye.